Hey everyone. Today I wanted to share something that's completely transformed how I work with music software and might actually transform a little bit how I make music in the future as well. So, a few weeks ago, my colleague and buddy Keith sent me an article by Jean Beauvais called When the Spec Becomes Code. At the time, I'd been using Claude, the LLM by Anthropic, to build scripts for Norns, and also to try out building scripts for the Seat Lombard Shunt and the Organelle M. And it was kind of what people call vibe coding. And you just go to the Gen AI, you write a prompt, and you kind of hope it generates something that works. And it kind of worked, but barely. I felt that I needed to come up with all of the answers before I activated the prompt. Excuse me. The problem wasn't that the code was bad. Claude actually writes pretty good code. The issue was that I'd have these grand ideas in my head and I'd try to explain them in a single prompt or a conversation. And no matter how detailed I tried to be up front, something would always get missed. Features would be half implemented, the architecture would drift, and I'd end up spending more time fixing things than actually creating music. And the problem was that I felt like I had to come up with all the answers before I involved Gen AI, and then when I gave it the answers, I said, just start coding. And that's really where Jean's article kind of gave me a little bit of a breakthrough. And so I read Jean's article and everything kind of clicked. And the key insight is this, that instead of trying to generate code directly through endless prompts, you focus instead your work with your ChatGPT or your Claude. You focus on creating a detailed specification first. And so you do revs again and again, and exhaustive revs, chatting to your LLM to generate a detailed specification, a spec that describes what you want to build, not how to build it. And the magic bit is when you collaborate with an AI like Claude on the spec instead of the code, you're having a conversation at the right level of abstraction. You're thinking about features, user experience, and system architecture, not semicolons and function names. The way I'd put it is that when I was going to Claude originally, I wasn't thinking through each of these parameters and what they needed to do. But by simply going to Claude and saying, hey, I want to generate a synth, a SuperCollider synth, let's talk about what the different parameters could be, Claude would naturally be more exhaustive than I was and ask me lots of questions. It would assume some things and say, hey, you know what, I'm going to implement glide time and I'm going to set it as a default of 0.01. Now, I wouldn't want that, but it was good that it had thought through that and introduced it. And so basically, the spec becomes your source of truth. It's written in plain language that anyone can read and understand, not just programmers. I'm certainly not one of them. And when you're ready, the AI can compile that spec into the actual working code. As Jean puts it in the article, the spec becomes the source code and LLMs become the compiler. This changed everything for me. Instead of starting with code and hoping it matched my vision, I now start with a clear specification. I iterate again and again and again on that specification, refine it, add details, remove ambiguity, and then I ask Claude to generate the code. And the difference is night and day. I'm getting to working prototypes so much faster. And when something doesn't work, I don't have to dig through code, I just update the spec and regenerate. The possibilities feel endless now. Which brings me to what I've been building and how it evolved into something even more ambitious. So let's take a look at what is currently called PolyNexus. PolyNexus started as Nexus, a generative chord instrument built around the grid controller. Top row lets you select between 16 different chord slots, and each chord can be any combination of notes, from simple triads to complex extended voicings. You program your harmonic palette and then perform by triggering the different chords along the top. If I just go into, here's a reason why it's not ready for production, because I've stupidly got all of the Nexus settings underneath all of the LFOs. Here you can see the different scales. I'll put it in C Mixolydian. that you can select, and then these will be different voicings in CMix. The generative engine probabilistically re-triggers notes from your selected chord on the clock. So if I press play, we are selecting different notes from this chord. If I press this button, then we will start cycling through the chords as well. You can set a tempo and a probability percentage. And every whole note, the engine looks at your current chord and decides whether to re-trigger each note. This creates evolving organic textures that never quite repeat the same way twice. There's also a bass and a sub-bass, sequencer that adds rhythm and low-end foundation. There you can see the bass sequencer kicking in, and here's the sub bass. Then, if you want more direct control, row 5 gives you these lovely higher notes that you can just play. They're all in the scale, so you can't hit a wrong note, which helps if you're not the greatest musician in the world like me. Now, initially, I built this using mx.synths, a great collection of polyphonic synthesizers for Norns. It worked beautifully, but then I thought, what if I could design the exact sound engine I wanted? And so that's exactly what I did. I created PolyVoice, a custom 6-voice polyphonic synthesizer engine built specifically for this instrument. I based it around 3 of my favorite Plaits models from Mutable Instruments: the Morph oscillator, the wave shaping oscillator, and the wavetable oscillator. But I didn't stop there. I added wavefolding for harmonic complexity, sample rate reduction for lo-fi character, independent LFOs for each voice, and comprehensive envelope control. It's a proper synth engine built from the ground up using SuperCollider. The beauty of spec-driven development really shone here. I could describe exactly what I wanted the synth engine to do: oscillator models, modulation routing, voice architecture, and Claude helped me implement it correctly in SuperCollider. We iterated on the specification together until every detail was right. And then I integrated PolyVoice back into the main instrument, and suddenly Nexus became PolyNexus, a complete, cohesive system. And we've got lots of effects in here as well. It wouldn't be me if there wasn't lots of effects. And so let's just hear some of those. Let me just turn up the tape wet boost so you can hear. We've got some funky sample rate reduction going on there with audio rate modulation as well. But we've got wow and flutter. We've got tape saturation. If I turn the effects mix right up and then really boost that, you can hear that kind of broken sound, which is great. We've just got a little bit of slower reverb on here, not much at all. And if I just go back up to the synth engine itself, you can see we've got a wave folder here. Just going to turn that mix right up and the fold amount right up as well. I've got an LFO controlling the fold amount as well, just lightly. And this sample rate just sounds great as well. You can just create really, really broken things. Bit Crusher isn't working quite as I want it to yet. Need to work on that. You've got noise generators as well. And let me just cycle through the wave shaping oscillator. Oh, and the 2-operator FM oscillator as well. I want to implement more different types of oscillator in PolyVoice for PolyNexus as the filter. But at some point, I was just having so much fun adding stuff. I was like, I've got to stop and show this thing off a little bit. So that's what I'm doing. I hope to have it ready for the world in a couple of weeks. I just want to debug a few things and clean a few things up. And so look, everything, sequencer, synthesizer, effects came together through this iterative process of specification refinement. And instead of getting lost in SuperCollider syntax or debugging MIDI routing, I could focus on the musical experience. What should each oscillator model contribute? How should wavefolding respond? What type of tape character feels right? And so PolyNexus isn't just a Norns app, it's now a complete instrument. And spec-driven development made building it not just possible, but genuinely enjoyable. And so, look, to close, I'm going to play a little performance on PolyNexus. I wanted you to hear it as raw as possible, but it wouldn't be me if I wasn't introducing a couple of effects. So we're going to add some slower reverb. I'm not a huge fan, maybe I just haven't kind of played around with it enough and got the setting I want, of the Norns on board reverb. Plus, I'd like to have reverb after other effects. And so that's why I'm using slower here. But until the end of the performance, it's not going to do much. And then about halfway through the performance, I'm going to add some onward as well, just for some kind of extra interest and effects. But look, most of what you're hearing in this performance is just PolyNexus itself. As I mentioned, with a bit more refinement and development, I'm planning to make PolyNexus available publicly so anyone with the Norns can try it. Whole package, the PolyVoice synthesis engine, gen sequencer, and the tape effects and everything. But more than that, I want you to try spec-driven development for yourself. Whether you're building music software, web apps, or something completely different, start with the specification. Get that right, iterate on it, make it crystal clear. The code will follow. And don't be afraid to be ambitious. When I started, I thought building a generative sequencer would be enough, but spec-driven development gave me the confidence to go further, to build a complete synthesizer engine from scratch in SuperCollider, to integrate complex effects processing, to create something that feels like a real instrument. And that's the power of this approach. You're not limited by your coding skills or your ability to hold the entire system in your head. You're only limited by your ability to describe what you want to create. Thank you very much for watching. And if you want to learn more about spec-driven development, check out Jean Beauvais' article. I'll link it in the description. And if you're interested in PolyNexus or just want to chat about music technology and synthesis, drop a comment below. See you next time.